Okay, we're in section 31 of the notes. This is the section on slope of a line. And we covered that. We covered the concept of what slope is, at least visually, and then through an abstraction, talking about the change in y divided by the change in x, or the delta y over delta x. We also gave you a formula. Again, if you look at the sides next to these formulas, if you're not paying attention during class, you can always, certainly you can always rewatch the lecture, but you can also play these little spot videos to learn the material as well. We also had a simpler way of doing it. If we were given an equation of a line, if we solve for y and we could determine the coefficient on the x, we knew what the slope was. Again, if you want to watch those videos again, you can, including the full lecture. We went through examples to get those points across. Hopefully, by going through those examples, you learned the type of questions you're going to see and how to do those questions. Then, of course, after you study that material, our hope is that you've actually done the homework. Now, what homework are we talking about? The homework is embedded in the notes. All right, so what I'm going to do is I'm going to switch to the whiteboard. Just give me 1 second. And I'm going to go to a new whiteboard here. Just give me a second with this. And I got to warm my machine up here. Just turned it on. And we have a new whiteboard. Now, certainly the notes have disappeared, but you should have the notes in your hand and your notebook with these problems already solved. This is sort of like an interactive checking. You're looking at my work, you're looking at your work, making sure things look fine. We're in section 31 of the notes. This can be a short section, and we're doing the homework. Number 1, what does it say? Find the slope of the line containing these 2 points. P1, I'll do this a variety of ways. I'm not asking you to do it a variety of ways. You need to find a way that's going to work for you. These are the 2 points over here. For some students, labeling the points helps them. This is the first point. That's x1. This is y1. This is the second point, x2, y2. What's the formula? M is y2 minus y1 over x2 minus x1. What's y2? Minus 6. What's y1? 5. What's x2? 3. Now we have a minus 4, which is plus 4. We have an answer key to look at. Don't worry about that. Minus 11 over 7. That is the slope of the line. I would recommend you look at the answer key. Make sure you're looking at that. And if you're not, there's something wrong with either the answer key or what you're doing. All right. I want to do it another way. The other way I want to do it is just simply talk about the changes and things. So I'm going to make a little table up. And this is going to be x and y. First and second is incidental when you're looking at this, but I'll put this down over here, minus 4, 5. Again, I'm not asking you to do it 2 ways. I'm just simply saying you need to know how to compute slope given 2 points. I'm going to talk about delta x, and I'm going to talk about delta y. All right, so delta x, I'm going from minus 4 to 3. I hope you realize that's up 7 units. I'm looking at the delta y. If you're at 5 and you went down to minus 6, right? You went down 11 units. What's slope? Let's write this down for you. Slope is delta y over delta x. And what's that going to give you? Minus 11 over 7. No surprise there. We get the same answer. All right, so we did by formula. We also did it by a delta y, delta x by looking at a table. Let's go to number 2. And in number 2, what I want to verify is certainly the work we're going to put down, and then certainly the answer. If the answer matches with their answer, I think I'm pretty good about that. So P1, very similar to the first question. And P2, again, very similar to the first question. Let's put this down. This is x1, my first point, and this is y1. This is x2, my second point, y2. All right, what slope? If you're using a formula, it's going to be y2 minus y1 over x2 minus x1. Let's write this down. Y2 is minus 5. Now you're going to subtract away, minus 5. So it's going to be plus 5. What goes on bottom? Minus 7, minus 8. What do you get on top? 0. What do you get on bottom? Minus 15. What does this give you? 0. All right. Of course, you should look at the answer key to verify that, in fact, it does say 0. I want to do it another way. Do it by the table. No, you don't have to do it two ways. You have to do it the way that you feel comfortable doing it. XY, this is going to be 8 minus 5. That's my first point. My second point was minus 7 minus 5. Can I look at this? Put the delta y down and the delta x down. What's delta x? If you're at 8 and you go to minus 7, you want minus 15 units. If you're at minus 5 and you got to minus 5, you didn't go any units. What's slope? It's delta y over delta x. What's delta y? 0. What's delta x minus 15? We still get 0. You should see these being remarkably the same. All right, they really are remarkably the same. What do I have over there? I have the answer. It says m equals 0, and I feel good about that. Let's go to number 3. Again, a little more wordy on number 3. I'll write it down for you. And again, we're still doing the homework. And again, I'll write the equation down. You get 3x equals 2y minus 6. Now, certainly I'm reading, it does say find the slope, the b, x-intercept, and y-intercept of the line whose equation is. Well, I'm going to write down a few things first. I'm going to write down the x-intercept. How do you get this? Set y equal to 0. What would that get? What would that give you? It would give you 3x equals minus 6 or x equals minus 2. All right, so I'm going to write the x-intercept down as a point, minus 2, comma 0. That's done. Let's write the y-intercept down. How to get a y-intercept? Set x equals 0. What do you get? Well, 0 equals 2y minus 6. I'm going to say it's pretty obvious, but again, if you need to, add 6 to both sides and divide by 2, that's fine too. What do you get over here? 3. So what's the y-intercept? The y-intercept would be, let's see, 0 for x, 3 for y. All right. What else do they ask for? They ask for the slope. Now, if I'm doing slope, I can use those 2 points to do it. And again, we can write the formula down, but I'm getting better at this now. So I'm going to say 3 minus 0, and that's changing the y's, and the change of the x would be 0 minus a minus 2, which is plus 2. So what's the slope? 3 over 2. All right, I'll put a box in that. I'll put a box in this over here too. They did ask for it. That's why I'm putting a box on it. So they asked for slope. I got that. X-intercept, y-intercept. I didn't get the b. So what's the b? The b is the y-coordinate of the y-intercept, which is the number 3. All right. You can look at the answer key. We are going to do this slightly different, and I want to see if I got the right answers. What did they say? M is 3 halves. We got that right. What did they say? B is 3. We got that right. What did they say the x-intercept is? Minus 2, 0. We got that right. What did they say the y-intercept is? 0, 3. We got that right. I want to do this slightly differently. We're still doing problem number. What number did we just do? Make sure I did. That was 3, right? And I'm still doing 3. The other suggestion we have for 3 is to solve it for y. If you can do that, you would get mx plus b, if you can do it. Let's see if we can do it. So it's going to be 3x plus 6 equals 2y. Then what I'm going to do is divide both sides by 2. You would get 3 halves of an x plus, well, 2 goes into 6 3 times equals y. So what is going to be? Y equals 3 halves of an x plus 3. So by looking at this, I know the m is 3 halves. I know the b is 3. And I know the y-intercept, 0, 3. What I don't know by looking at this is the x-intercept. How do you get the x-intercept? Again, just like we did before, you're going to set y to be 0 and solve. Where would I do that? Probably up here. It's pretty simple. What would you get? 3x equals minus 6. So x would have to be minus 2. Do we get the same answers? Of course we do. We see m is 3 halves. We see b is 3. We see the x-intercept minus 2, 0, and the y-intercept 0, 3. You do it the way you're comfortable though. Don't think you have to do it one way or the other. All right, let's go to number 4. And again, I'm just going too quickly for you. You probably haven't studied, and you probably haven't done the homework yet. All right, if you've done the homework and studied, this should not be going quick for you. You're just looking at your notes and verifying what you got is correct. So, you can always watch these videos at the end of the week as well. And if that helps you, that's fine. Let's put this one down. Number 4, same question. They want to know, slope, x-intercept, y-intercept, b, yada, yada, yada. Same question. All right, so I'm going to write this down. I'm going to write down the x-intercept. All right, what do? Set y equal to 0. Well, if you do that, you're going to get minus 3x equals 7. Relatively simple. X would be minus 7/3. That's 3. Okay, so I know the x-intercept. What's it going to be? Minus 7/3, comma, 0. I'm going to put a box in that because they did ask for it. Now I'm going to put the y-intercept down. How do you get a y-intercept? Set x equals 0. If you do that, what do you get? 2y is equal to 7. All right, what does that mean? X equals 7/2. We have an answer key to look at, and we will be doing that once we're finished. Get the y-intercept. Okay, slope. I don't recommend it, but you could get slope from this. How do you do that? Change in y's. 7/2 minus 0 over the change in x's. 0 minus a minus would be plus 7/3. What does this give you? 7/2 over 7/3. I would multiply top and bottom by 6. That's the minor LCD. Again, I don't recommend this, but you could do that. What do you get on top? Well, 2 goes into 6 3 times, and 3 times 7 is 21. What do you get on bottom? 3 goes into 6 2 times, and 2 times 7 is 14. Certainly divisible by 7. What do you get? 7 goes into 21 3 times, and it goes into 14 2 times. So now I have the m. This is the m. What's the b? The b is the y-coordinate of the y-intercept, which would be 7/2. I just want to go to the answer key and look at it, see if I have those answers down. I have the m, 3/2. I have the b, 7/2. I have the x-intercept, which is minus 7/3, 0, and the y-intercept, which is 0, 7/2. I want to do it differently, though. So I'm going to do problem number 4 all over again. This is my preferred method. So number 4, what do you see? 2y minus 3x equals 7. What I would recommend you do is get in the form y equals mx plus b. Let's put that down. 2y equals, I'm going to add 3x to both sides, and then I'm going to divide both sides by 2. What do you get? 3 over 2x plus 7 over 2. Immediately, I know what m is. What's m? 3 over 2. Immediately, I know what the b is. What's b? 7/2. Immediately know the y-intercept, because I know the b. It's 7/2. Again, we'll check in the SQ later. X-intercept, a little more challenging, but it's really the same story. What do? Set y to be 0. I would do that up here because it's easier for me to do that. And what would you get? If y is 0, you would get minus 3x equals 7, or x equals minus 7/3. Again, we'll check this in the key in a second. All right, let's look in the key again. What does it say? M is 3/2. Got that right. B is 7/2. X-intercept, minus 7/3, 0. Y-intercept, 0, 7/2. This is exactly the same answer we got from the other work. You need to find work that you're comfortable with, though. Not that I say you can do it 2 different ways. You find a way you can do it. All right, let me look number 5 down. A little more complicated. There's 3 points now. They want me to find the value of k such that the coordinates lie in the same line. If they lie in the same line, they have the same slope. So let me write the 3 points down. 1 comma k, 3 comma 1, and 5 comma 0. So what I'm going to do is I'm going to take these 2 points here and compute the slope for those 2 points. Let me write that down for you. So what's the slope for those 2 points? Well, change in y, 0 minus 1, and 5 minus 3. What would that give you? Minus 1 over 2. So I know the slope is minus 1/2. Now here's the deal. It's got to have the same slope between those 2 points. Let me write that down for you. So the m here, again, more common because it's an abstraction, there's a letter in it. It's going to be 1 minus k. And what goes on the bottom? 3 minus 1. What do you get there? 1 minus k. 3 minus 1 is 2. Well, let me write this down now. These slopes, this slope here must be identical to this slope, which means that 1 minus k over 2 must equal minus 1/2. I'm going to multiply both sides by 2. And what do you get? 1 minus k equals minus 1. That's not so bad. And then I'm going to do is I'm going to subtract 1 from both sides. And what do you get? Minus k equals minus 2. And I think it looks pretty obvious now. K is equal to 2. Now, could I have made a mistake? Of course I could. All right, let's take a look. And I'm going to look at the key. And what they say? Well, they say k is 2. So I feel good about that. Going to the next question. And next question, again, you might be confused by what you're reading. I hope you're not confused because we've done problems like this similar to class problem, and similar to this in class. So number 6, what do you see there? X equals 3/4 y minus 2. Now granted, they do say graph the line. I'm going to stop reading there. To graph a line, what you need 2 points. I'll put the 2 points down for you. The points I'm going to select are ones that are easy for me. I like integers because they're easy for me. Why did I choose y to be 0? Because it's easy for me. What would this give me? X equals, well, if y is 0, 3/4 times 0 is 0, and 0 minus 2 is minus 2. So I know what x is. Now I'm going to pick another easy value of y. For me, it would be 4. What would you get? Let's write this down. X equals 3/4 times 4 is 3, and 3 minus 2 is 1. So I have 2 very simple points. Again, all I read was a couple of words of that sentence. It said graph the line. I'm going to graph this line now. So minus 2, 0. All right. And what's the other point? 1, 4. All right. Now, granted, I'm not going to say it's going to be the best looking line, but yeah, it's going to be a line. Right? And that's what I mean. It's going to be a line. It's not going to be the best looking line. Now, if you're doing this in WebAssign, it's probably not going to look bad. All right. But before I do that, I want to read this to you. It says I should find the slope of this line. Let me put that down for you. Well, I'm looking at it, and I'm just going to write down for you. It's 4 minus 0, 1 minus a minus 2. So the slope is going to be 4/3. All right. They also said y-intercept. Let me write this down for you. They said I should use it. Well, we'll talk about it. I got the slope. All right. I got the slope. We'll talk about using it later, by the way. And what I'm going to do is the y-intercept. Now, how do you do y-intercept? Set x to be 0. Let me write this down for you. If x is 0, what do you get? 3/4 of a y minus 2. I'm going to add 2 to both sides. I'm going to multiply both sides by 4. And I'm going to divide both sides by 3. That's a nasty number. Someone says, I wonder what 8/3 is. Well, 3 goes in 8, 2. I'll write this over here for you. It goes in 2 and 2/3 times. So if someone said where that would be, it's 2 and 2/3 up. Well, it's right over here. All right. I am going to make an attempt to draw a line through those 3 points now. All right. I'll do my best job possible. Okay. Okay. Someone says, did you really use the slope to graph that line? And I'm going to claim I did. And I'll tell you why I'm claiming I did. I'm going to look at this over here. And what does this over here? It says the run is 3 and the rise is 4. So if you took this point and you ran over 3 and then you would rise up 4, you'd hit this point over here. Now, did I use the y-intercept? I did, but I'll be honest with you, it wasn't very helpful. I did know it went through the y-axis. So we're done with this problem. I'm going to go to number 7 now. 1 second to push this up. I'll put down number 7. Whoops, sorry about that. What's 7? It's really the same question. It basically says you have a point. I'll write this one down for you. Minus 1, minus 2. And you have a slope. And what do they want me to do? Graph a line. How do you graph a line? You absolutely need 2 points. So I'm going to tell you what this means to me. This is delta y over delta x. I'll put this down for you. Delta y, it says it's minus 3. Delta x, it says it's 2. Let's do one at a time. Let's do the x first. If you're at minus 1 and you go up 2, that's what the delta x says. Where would you be? You would be at 1. All right. If you're at minus 2, and this is the y now, and you go down 3, why do I say that? Delta y is negative 3. Where would you be? Let's see, minus 2 minus 3 would be minus 5. I have my 2 points. I'm going to graph those 2 points now. Again, these are rough pictures. It's an abstraction, and it's good enough for me. So I'm going to say minus 1, minus 2, right here. What's the other point? 1 minus 5. What am I going to do now? Draw a line through those points. Don't worry about it too much. Okay, so I certainly in the key I don't have a visual there, but yeah, what I'm looking at there is I'm looking at a graph that they didn't give me a visual though. So what I'm going to claim over here is, maybe we'll use software to do that, but we'll do it later. Right? What I'm looking at, did I get the same points they said? So I'm looking at it. This was a given. This would be hard to get that wrong. I noticed they put another point down there. They put minus 3, 1 down. Let's take a look at that. They wrote another point down, and I'm going to write that down for you. What I want to claim is it appeared they went in the other direction. So the delta y would be 3. And if I go in the other direction, the delta x would be minus 2. Well, if you're at minus 1 and you go down 2, you'd be at minus 3. If you're at minus 2 and you go up 3, you'd be at 1. However, please feel free to choose the points you want. All right. Again, if you were to do that on the graph, minus 3, 1 would be over here somewhere. All right. Minus 3, 1 up. All right. It's still on the line. You get comfortable with these, though. Don't let someone tell you that one point is more important than the other. You just need 2 points on the line. Let's go to number 8. And what's number 8? I'll read it to you. It says graph the line that goes through the point 9 minus 6 and has slope minus 1/8. All right, I'll put this down for you. Again, the graph a line, you need 2 points. And I'll write this over here. And this is 9 minus 6. I'm going to put the delta y down. What's a delta y? Minus 1. And what's a delta x? Again, we're going this direction here. What's a delta x? Looking at it, it's 8. Now, granted, it's kind of crazy to go in that direction because it might be a lot of counting, but I think I can do it. And let's just take a look at one step at a time. I'm doing the y first. If you're at minus 6 and you go down 1, I hope you realize you get to minus 7. Now, if you're at 9 and you go up 8, you'd be at 17. Now, I got to be honest with you, for a lot of students, 17 is way too big for them. So I want to do it a different way, just like we did before. But again, you feel free to choose the numbers you want. So what I'm going to do is go like this over here, all right? So delta y would be 1. Delta x would be minus 8, going in the direction. So let's take a look at that. If you're at minus 6 and you go up 1, where would you be? Minus 5. If you're at 9 and you go down 8, you'd be at 1. Now, I'm going to say for most students, these points here are probably easier than these ones over here, but you decide. I'm going to put my graph down. And the first point I want to put down is 1 minus 5. The other point I want to put down is 9 minus 6. Let me see, I count. 1, 2, 3, 4, 5, 6, 7, 8, 9. And minus 6 is over here somewhere. Draw my line through it. Don't worry about the great artwork. This looks like a line. We'll accept it from you. And that kind of looks like a line to me. All right, so I'm going to go to, I should look at the answer key to make sure you're staring at these points. What points are we talking about? Well, 9 minus 6, and I also write down 1 minus 5. All right, not bad. All right, we're following that. I'm going to switch back over to the notes. right? We're done with that assignment. Generally, these assignments, once you understand the material, they should be incredibly simple to go through. So we can go back to the notes. So again, I'll do technology later, but before I do that, again, my goal here is, not to, beat you up with this material, is to present it to you such that you can do well on exams. All right. Now, someone says, is that my goal in life, just to get by on the exams? You should start thinking about maybe thinking that this is a bigger topic than we're suggesting it is. And it really is. Algebra is a much bigger topic. So are these problems we're talking about with these integer solutions or Diophantine equations, right? So I'm seeing that on my notes. I'm seeing this thing over here, optional read. If you like, you can read through that. It was an interesting question. And basically I copied it almost verbatim from the internet. It was a question from this guy over here, Chris, and he asked about integer solutions to the equations x plus by equals c. And he's asking Dr. Math. And Dr. Math answers the question nicely too, by the way. So I'm going to point out, looking at it, if you want to read through that, you can. If you read through that and you're glazing over, you really have to start thinking about doing something different. We're not looking for you to glaze over. All right. So I want to get to Sage. I want to point out there's a reason for this. Sage is just an introduction to using a computer to program. Programming can be very, very difficult. All right. So I'm going to talk about other options for you. But before I do that, I want to make sure you know what we're doing. We're going to the Sage website. Boy, have we done this too many times at this point. You should be very comfortable going there. Very comfortable creating a document. I'll do that for you, okay? And very comfortable typing in the code that we present to you. Yeah, we've done it way too many times, I think, right? It's starting up. Any minute now. But I'll tell you why it's slow. The internet, this is using somebody else's computer, and they may not want to serve a resource at this point. They might be doing something more important. They might be doing their own computations. So I'm going to say reset. Remember, shift return. I got that. Yeah, it's working on it. X and Y are variables. This is so typical in computer science. We define variables. I'll write that down for you. I'm just typing what I'm seeing. Hopefully you're learning as you do this. This looks like a long one. What do they want me to do? They want me to plot. So I'm just going to copy paste. I'm tired, right? Working on it, and drew the picture of it. I don't think the picture is great, though, to be honest with you. It's good, though. It certainly represents what they want. And what they do, they graph the line 2y minus 3x equals 7. What I want to do is go to Wolfram Alpha. And what I want to do is, I just want to go back over the problems to point out we can really graph these guys pretty easily. It'd be much nicer than we could ever do by hand. So I'm going to I'll do number 3, okay? So graph 3x equals 2y. You don't have to put a star in. It's really a much nicer software package. And even the creators of Sage say the same thing. These are better packages. There's no doubt about it. People spent a lot of money on this. However, a lot of professionals won't go near Mathematica because it's closed source. Sage is open source. They can actually look at the code. But anyway, graphs the line. Looking at it, you can get the y-intercept, the x-intercept, and get the slope from that as well. And certainly, it's easy to do. I mean, you really can put this down. And for example, number 6, I'll just type that in for you. And what is that going to be? X equals 3 divided by 4. And then, I'll write it as 3y because it might confuse you. 3y divided by 4, and then minus 2. All right, so one thing I want to point out when it does that, it writes it in a way that you may find peculiar, right? But it's really the same thing that's over here. It's 3y divided by 4 minus 2. All right, let me go back to another way of writing it down. And this might look strange to you. We're going to see how it typeset it. It typeset it better, didn't it? It said x equals 3/4 of a y minus 2. Right, not bad. We can do this for all the problems, including much more difficult graphs, by the way. Much more difficult graphs. All right, that closes this out. Hopefully this made sense to you and that you're ready to move on. Thank you.